Section 3.4, angles of a triangle. We have 3 objectives in this packet. This warm-up we're going to do in the class. Okay, so we skip this warm-up. Okay. All right. So we are here. We have 2 more sections, and we don't do 3.6, and we are done with chapter 3. Okay. Objectives 1. Classify triangles according to size and to angles. Okay, so size and angles, classifying triangles, objective 1. Okay, so a triangle is a figure formed by 3 segments joining 3 non-collinear points. Each of the 3 points is a vertex of a triangle. The plural of vertex is vertices. The segments are the size of the triangle. Here is a triangle. So we usually call, so this is BC. Okay, these are the points. If we have a side, then we usually call the angle opposite that side the same name. But in this case, it's just the 3 points, so it doesn't matter. Okay. Here are the different classifications of triangles. The scaling triangles are 3 different sizes. So these are the classification by size. So either 3 different sizes, or 2 are the same and the third is different, or all 3 are the same. Okay, so that's a scalene, isosceles triangle, and equilateral triangle. And by the angles, here is an acute triangle, meaning that all 3 angles are acute, acute meaning less than 90. Obtuse triangle, 1 angle is obtuse, 2 others are acute. You can't have 2 obtuse angles. Think about why. Okay, we think about this later because this is one of the corollaries that we learn. The right angle, 1 right angle, and 2 other angles are acute. Okay, and if the 3 angles are congruent, then it's called equiangular. Okay, so this is a little bit helpful to do Venn diagram. So let's see over here where the space is. Okay, so here is a triangle. Triangles. Okay, and if 2 angles are the same, it's called isosceles. And for equilateral triangle, the 2 are the same, right? 2 are the same, and just the third side happen to be the same length as this. So equilateral is a special kind of isosceles triangle. So if you have isosceles triangle, equilateral is in here. Okay, so this is all the triangles. That's isosceles. Inside here, the special kind of triangles are isosceles. Even more special is equilateral. So where does scalene is gonna go? Is scalene another circle? That's a scalene. Does scalene overlap with isosceles? What do you think? Write it down where you think it's gonna go. Okay, so can a triangle be scalene and isosceles at the same time? The scalene means 3 different sides. Isosceles means 2 the same size. Yeah, they can't overlap. And is there any other possible way the triangle be other than the 3 same sides, 2 same size, or 3 sides are different? Yeah, those are the only ways, right? So scalene is the rest. It's not in the bubble. Everything else is a scalene. Okay, so inside the triangle, it's either scalene, isosceles, or equilateral. Okay, and let's just layer this in the angles. Okay, so can acute angle be scalene? Yeah, this is a scalene acute triangles. Can acute triangle be isosceles? Think about it. Yeah, it can. So acute is kind of like this. Okay, can it be equilateral? Can acute angle be equilateral? Yeah, Acute can be equilateral. So actually, that's not where it goes. It should be more like this. Right? That's acute. So acute triangle can be scalene, isosceles, or equilateral. Okay? And obtuse triangle. Can obtuse be in scalene? Yeah, this is scalene. Can it be isosceles? Yes, it can be isosceles. Can it be equilateral? No, it can be equilateral. If you don't see this Y, we see this later, okay? But obtuse is like this. Okay, it can be scalene or it can be isosceles, but not equilateral. How about right triangle? Can right triangle be scalene? Yeah, this is a scalene. Can right triangle be isosceles triangle? Yes, it can. How about equiangular? No, how about equilateral? It can be equilateral, and then you will see why. Okay, so right triangles over here. Triangles, obtuse triangles, and acute triangles. Okay, and where does the equiangular go? Three angles are the same. You haven't done this, but if they are three angles are the same, then three sides have to be the same. So equilateral and then equiangular are the same thing. Okay, so this is, that's why I wrote it equi here, because it could be equiangular and equilateral segment and angle. Okay, so that's the idea of the classification. Okay, so based on this, you can do this. Okay, so you do this for homework. All right. Here comes the triangle angle sum theorem proof. I think you learned this in middle school that the angle sum triangle is 180, but you didn't prove this. So that's new here. Okay, so here we go. I'm gonna give you the statements and also the reason for the first line. You do the rest, because given is just the triangle ABC. That's all that is given. So this is the triangle ABC is given, and these angles and this line you have to draw on the diagram. So the first thing is you draw this line here through B. Draw line BD parallel to line AC. No, I spelled parallel. Parallel to line AC. And the reason is through a point outside of a line, there is exactly one parallel line. Do you remember this one? This was in 3.3. We didn't spend much time on, but there was a line and line outside the line. There's only one parallel and only one perpendicular. That's this one. Okay, so you can draw a line through B, and there's only one line that can go through there, parallel to AC. Statement 2. Measure of angle DBC equal measure of angle phi plus, no, measure of angle DBC plus measure of angle 5 equal 180, and also measure of angle DBC equal measure of angle 4 plus measure of angle 2. Reason, okay? Reasons homework video. All right, and so after this, you can go here measure of angle 4 plus measure of angle 2 plus measure of angle 5 equal 180. Reason 4. Measure of angle 4 equal measure of angle 1. Measure of angle 5 equal measure of angle 3. Reason. And 5. Measure of angle 1 plus measure of angle 2 plus measure of angle 3 equal to 180. Okay? Reason. And we are done. Okay? All right, next. Corollary to theorem 311. The statement that can be proved easily by applying a theorem is often called corollary to the theorem. Corollaries, like theorems, can be used as reasons in proofs. Each of the 4 statements that are shown below is a corollary to theorem 311. Now these ones you have to spell out when you use them in the proof, okay? So let's go over them. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angle are congruent. Why is that? Think about this. Triangle 1, triangle 2. If these angles are the same and these angles are the same, then these angles have to be congruent because they have to add up to 180, right? Must add up to 180. All right. Corollary 2. Each angle of an equiangular triangle has measure 60. Equiangular triangle means 3 same angles. So 180 divided by 3 equals 60. And that's why the equiangular triangle has a 60-degree angle over 3. And that's why the equiangular triangle cannot be isosceles or scalene. Okay? And also now you see here, if one is right angle, right? Then two other angles cannot be the same angles, cannot be 90 because they have to add up to 180, right? So that's why right angle cannot be equiangular or equilateral, and obtuse cannot be equiangular or equilateral. Okay, that's because they have to add up to 180. Okay, so if this angle is 90 and these angles have to add up to 90, right? Because total have to be 180, this is already 90, so these angles have to be complementary. And if this is more than 90, then some of these two have to be less than 90. Okay? All right, let's look at the corollary 3. In a triangle, there can be at most one right or one obtuse angle. That's what we just said, right? The sum of 2 other angles must be less than 90. Okay, if it's a right angle or obtuse angle, then some of the 2 other angles must be less than 90. Okay, well, it can be 90 if it's a right triangle, but if it's obtuse, it have to be less than 90. All right, corollary 4. The acute angles of a right triangles are complementary. Yeah, because all 3 have to add up to 180, and this is already 90, so these have to add up to 90, and therefore they are complementary. Okay, here is a practice. Can you conclude that angle P equal angle B? Just do a quick proof here, okay? Homework. You can do this. All right, here is exterior angle of a triangle, and okay, so we missed the objective 2 and measure of triangle. All right, so objective 2 and objective 3 we missed it. We didn't write it. All right, so let's write it here. So objective 2 was, so go back to this page, okay? Page 4. Okay, before the theorem 3.1. The objective 2 was state and apply the theorems and the corollaries about some of the measures of the angles of a triangle. Okay, state and apply the theorem and the corollaries about some of the measures of the angles of a triangle. That's objective 2. And then we did the 3.11, and then we did the 4 corollaries associated with 3.11. That was objective 2. And objective 3 right here is state and apply the theorems, the theorem to singular, about the measure of an exterior angle of a triangle. Okay, so that's objective 3, and that's where we are here, right? Exterior angle of a triangle. Okay, when one side of a triangle is extended, like this, one side of the triangle is extended, an exterior angle is formed as shown in the diagram below. That's an exterior angle right here. Okay, this is exterior angle right here. Okay, because an exterior angle of a triangle is always a supplement of the adjacent interior angles of a triangle. This is always a supplement to the interior angle of a triangle. This is supplement to interior angle of a triangle because that forms a line. These two are linear pair, right? Linear pair. Its measure is related in a special way to the measure of the other two angles of a triangle called remote interior angles. These two are called remote interior angles. Okay, remote interior angles. Now, how many exterior angles does a triangle have? One triangle have how many exterior angles? I think most of you said 3, right? Because it's a triangle. That's where you're wrong. There are 6. Here is another one for this vertices. This is also 65. These are vertical angles, right? That's also exterior angle. There is 2 here. There is one that is 140, and there's another one that is also 140. And here is a 1 and another one. Okay, this is no exterior angle. That's no exterior angle. These are. It's the extended line of the side of the triangle made with the side of the triangle. That's exterior angle. Okay, so each triangle has 6 of them, 2 per vertices. Okay, all right, theorem 3.12. The measure of an exterior angle of a triangle equals the sum of the measure of the 2 remote interior angles. So measure of this equal this plus this. That's what the theorem 3.12 is. In the diagram, you know that 1 plus 2 plus 3 is 180, right? And you also know that 3 plus 4 is 180. Explain how these equations allow you to prove the theorem 3.12. So I want you to do that as a homework. Okay? So you gotta write it out like a proof. Okay? All right. And practice for the theorem 3.12, and I think we are done for this video. Okay. In triangle ABC, measure of angle A is 120, and exterior angle at C is 5 times as large as the measure of angle B. Find measure of angle B. So we just learned that this measure of angle is this plus this, right? So 5x equal 120 plus x. You can solve this, right? And you do these 3 for homework. All 3. These are not hard. You can do this relatively simply. Okay? And you're done. See you in the class.